Greetings to all the viewers. The session is going to cover with the compound called a triazole. Triazole, where we are having three heteroatoms. One is at the position number 1, 2, and 3. Either it may exist in the form of 1, 2, 3, or else 1, 2, 4 as well. Two possibilities we can notice for the triazole molecule, and the session is powered by AI artificial intelligence powered session we are going to conduct. And here is the triazole molecule where three nitrogens and two carbon atoms resided within the molecule, and one of the nitrogen linked with the hydrogen atom, and two carbons are added with the hydrogens as well. This is the way numbering is provided. As already we know, preferential numbering will be started from that nitrogen atom, and that will be proceeded in the subsequent manner and giving rise to 1, 2, 3, 4, 5 numbering within the 5-membered heterocyclic ring system. Being the compound with three heteroatoms within the single skeleton, it is the kind of more potential towards various applications, right? Prefer IUPAC name is provided as 1, 2, 3 in case of this one, or else you may proceed with 1, 2, 4 triazole as well. And moreover, that hydrogen is located on the number 1 nitrogen. That's the reason why 1H 1, 2, 3 triazole, or else 1H 1, 2, 4 triazole. Being both are positional isomers, both the possibilities we have for these triazole molecules, right? Let me enter into the segment, a brief intro regarding this triazole molecule. Triazole is the kind of three heteroatoms containing 5-membered heterocyclic ring system. It is the 5-membered heterocyclic ring containing three nitrogen atoms resided either at position 1, 2, 3, or else position 1 to 4 as well, right? So this is the way the compound is accompanied by two carbon atoms within the compound, and molecular formula is designated as C2H3N3. Three nitrogens, two carbons, and three hydrogens are the part of this compound. There are two main isomers for this triazole. Either it exists in the form of 1, 2, 3 position, or else 1 to 4 position as well. So that both are said to be positional isomers based on the positioning of nitrogen atoms. Let me provide the structure for this compound. 1, 2, 3 triazole nitrogen atoms are located at the position of 1, 2, 3, and 1 to 4 triazole are located at 1 to 4 positions respectively as mentioned in this two possible positional isomers. And here is the significant moiety you can observe, where the triazole molecule is taken as a linking device between this is called isatin moiety, and this is called a kind of heterocyclic ring with a complete saturation. Dihydroartemisinin moiety with the anti-cancer activity is accorded for this one. So 1, 2, 3 triazole, the tethered dihydroartemisinin isatin hybrids, the entire molecule having the provision for the curation of cancer disease. Malignant tumors effectively curated, medicated by means of the kind of drug where the linkage is provided, bridging linkage is provided in between two heterocyclic ring system. One is said to be indole moiety called isatin. Another is a kind of dihydroartemisinin kind of moiety. Both are together joined with this triazole linkage, right? So this is the significant role of triazole in the field of medicine. Let me introduce some more drugs related with this triazole only. Here you can locate a 1 to 4 triazole molecule within this drug, where triazole taken as the effective pharmacophore and working like an anti-cancer drug. And both the compounds, the single compound is accompanied by this triazole, which is in contact with the benzene ring. And at the position number 2, you can locate the tertiary carbon atom upon nitrile is there, and even carbon number 4 is also located with the same kind of functionality. It is a trade marketed as anastrozole. Anastrozole is the marketed name for the compound. It is effective anti-cancer curative. Let me introduce another one where Letrozole is the name of the compound. Anti-cancer activity due to the existence of this effective pharmacophore. Triazole, again, it is linked with the diaryl compound. Diaryl nitrile is the function is the compound provided over this triazole one, right? So this is the way compound number 2 is also the example for anti-cancer curative. Let me introduce another drug called vorazole. Vorazole is another anti-cancer drug where triazole is taken, and upon this triazole we have biaryl linkage, and one more triazole molecule is located upon this benzene ring, so that it is having more intensified activity, being it is allocated by more number of heteroatoms and more number of heterocyclic ring systems within the compound. Again, it is the part of anti-cancer curative. And here you can notice that antifungal agent, which is accompanied by this triazole molecule. And here we have alkyl chain over the nitrogen. In alkylated product, it might be. And here the alkyl chain is very much lengthy. And here the carbon 1, 2, the second carbon is joined with the benzene. Chloro functionality is located over the benzene ring. And over this carbon atom, we have a nitrile linkage, and another 1, 2, 3, 4. Butyl side chain is also located upon this carbon atom. Together, the molecule is working like an antifungal agent. Fungal infections, dermatology diseases, skin related infections will be better curated by this one due to the amplification of fungal eradication by means of chloro and triazole together, right? So it is traded as microbutanil. Microbutanil is a marketed name for the compound where triazole is the effective pharmacophore whose activity intensified due to the existence of chloro in addition to this triazole. Let me introduce another one. It is a kind of isomeric form of the what mentioned now, microbutanil, and the same compound just shuffled within the molecule itself, and able to generate a kind of just a shuffled one, tuberconazole. Tuberconazole again containing that antifungal activity where triazole and chloro together intensifying this trifungal infection curation, right? So the effective medication is provided by means of this tuberconazole, right? Another triazole related drug will be upon the triazole, we have a lengthy alkyl chain. One side you can locate the common alkyl moiety, that is chlorobenzyl one. Another side you can locate again tertiary butyl branched system is located, and here is the hydroxyl functionality over the carbon. It is named as a paclobutranol. Paclobutranol is the antifungal drug. Again, fungal infections will be effectively curated. Three antifungal agents are having a common structural skeleton in general. There are triazole, there are chlorobenzene in common, and alkyl side chain is also commonly observed, and a kind of a butyl. Here is the butyl chain is there in the open chain model. Here is the branched one. Here is the branched again. This is the way antifungal drugs are having some extent similarity over there. And here we have rizatriptan. Rizatriptan is the kind of drug which is the combination of triazole and indole together, and it is the anti-migraine, able to relieve the pain of headache, right? So migraine conditions effectively curated. And here we have a triazole molecule in contact with the saturated furan, tetrahydrofuran it will be. And here the position number 2 is located with the amide linkage. Ribavirin is the name of the compound. Viral infections will be effectively curated. Viral in diseases medicated by means of this ribavirin drug. So these many marketed drugs are available which are composed by this triazole at its core. And in extension to the significant role of this triazole in the field of medicinal chemistry, let me introduce another anti-cancer scaffold, which is accompanied by this triazole moiety over there, polyannular system. With this triazole over there, that is the kind of anti-cancer activity is imbibed over. Alpha beta unsaturation is also taken at taken at this polyannular system. So certain extent it is having steroidal skeleton, and here we have a triazole, which is the effective pharmacophore for the fight against the cancer, right? NMDA receptor antagonist, which is in either medication, is provided over there. That is the quinoline derivative, and which together existing with triazole again. And here is the kind of the another nitrogen containing heterocyclic ring system. Many number of heterocyclic rings are taken into the consideration, which is also the effective medical auxiliary. Then triazole, which is in contact with the long chain C12H25, so that a 12 carbons length chain is located on this carbon number 4. And here is the kind of amide linkage. This is cholesterolemic activity, which able to regulate the lipid levels in the blood, so that cholesterol high fat content will be better regulated, so that blood clots will be mitigated and heart functioning will be uplifted. And another medicine anti-HIV activity is incorporated for the compound with the triazole, and more number of heteroatoms containing pyridine imidazole derivative, pyridine fused imidazole derivative, and this is anti-HIV immunodeficiency syndrome curative it will be. And next we have a kind of bicyclic ring system of this piperidine and triazole with methyl at a suitable position. Obviously, there is a position number 4 is available for this methylation. This muscarinic acid activity. So muscarinic activity is provided for this one. And here is the drug you can locate. Antihypertensive activity is given for this one, where triazole and again biphenyl ring system is there, and saturated imidazole is provided. This is effective against reducing the blood pressure. And here is the kind of system with the benzene fused with this dinitrogen containing 6-member ring system, and another benzene is there. Both are connected with the secondary amine. Here is the ether linkage. Here is the bromo. Here is the fluoromethoxy functionalities are located over the benzene rings at various positions. And triazole taken at as effective pharmacophore, which is the VEGF receptor tyrosine kinase inhibitor. So whenever tyrosine kinase inhibitor is working upon the pathogen, so that protein generation in pathogens will be destroyed, so that pathogen destroy is possible. This is the kind of effective antimicrobial agent, right? And here is the triazole related heterocyclic compound is provided, and triazole is highlighted being it is a effective effective pharmacophore and working against this NK1 antagonist activity. NK1 activity will be suppressed over there. This is the way multiple medical applications are manifested in the single slide. Let me go with the antiviral agent TSAO. TSAO, where this triazole is taken, and TBSO is also another functionality that is present. And here is the furan kind of ring, and the sulfone group is also provided. And here is the amide linkage upon this triazole nucleus, which is highlighted portion. The highlighted portion is this triazole, which is the antiviral drug it will be. And the antifungal agent with the multiple ring systems, where you can locate two molecules, two skeletons of this triazole. Just now we gone through this fluconazole compound, and where benzene ring is in conjunction with this kind of imidazole, so that it is an antifungal dermatology curative agent. And another anti-cancer agent is provided, where triazole is taken into at its core compound, and another benzene rings are also extended And here we have amide linkage, just like the starting material. Here also amide linkage over this triazole, which is effective tumor cell destroying agent, that is anti-cancer, anti-neoplastic. And again, in either anti-cancer medication, you can clearly observe mubritinib. Mubritinib is the kind of compound where you can locate oxazole ring, benzene ring, another benzene ring, trifluoromethyl functionality, and ether linkage is there. So at this terminal, you can locate the triazole, which is the effective pharmacophore working against the cancer. And antifungal agent with the Lindy chain, where multiple heterocyclic ring systems are taken part of this compound to increase the potency of the compound, where 2 moles of triazole will amplify the action towards this antifungal activity, itraconazole, so that it is most effective kind of antifungal drug. Moreover, these triazoles are in conjunction with the chlorofunctionalities again. Yeah, let me mention another antifungal agent in the similar kind, same kind of a triazole. It is also resembling the molecule, so that it may said to be derivative of this itraconazole. So you may replace chloro with fluoro, so that chloro whatever it kind be, it may exist, it may possess the kind of anti-infective tendency. That's the reason why. Let me replace chloro functionalities with fluoro, so that again they are having intensified antifungal activity. Let me introduce another triazole molecule with the amide side linkage, and here tetrahydrofuran, another, that is ribavirin. Already we gone through this, which is a potential antiviral drug. Trazodone is the antidepressant, where benzofused triazole is taken. So this is uplifting the activity of the brain. And here is the kind of triazole molecule with which is in contact with the another polyannular system, which is a triazolam. So here triazolam is the sedative and hypnotic, which able to induce the sleeping tendency, right? So sleeping disorders effectively curated by this one, so that the sleeping tendency will be induced. So this is the reason why the kind of triazole is very vital in the field of medication. So that we are trying to discuss about this molecule in detail. Let me enter into the segment called synthesis of triazole. How can we synthesize? There is the named reaction provided. Hesgin 1,3 dipolar cycloaddition is provided, where Hesgin 1,3 dipolar cycloaddition, which is the part of click chemistry. And the reactants are added. One is alkyne, another is azide. Azide is said to be as a compound it will be, and that to be added upon the alkyne, giving rise to a compound called a triazole. Copper is initiating this reaction. It works like a catalyst in order to facilitate the reaction, and a selective synthesis is accomplished. Reaction conditions need not to go for elevated, rather you can perform the reaction at room temperature itself. Often aqueous or organic solvents are necessary in order to carry the reaction. So that perfectly it is moving upon the green methodologies only. And reaction is accomplished in between the alkyne and azide together in the presence of copper catalyst, giving rise to triazole, which is a substituted one. So this is the way the reaction will be carried. And let me introduce the reaction. Whenever alkyne is treated with this kind of alkyl azide in the presence of copper catalyst, there is a origination of triazole as the final product. In order to get that reaction, there is a simplified mechanism provided. It is the kind of cycloaddition reaction that is said to be 1,3 dipolar. Cycloaddition reaction is performed in between this azide and acetylene together, giving rise to this kind of a triazole molecule within the sphere, right? In order to get that reaction, we have a detailed mechanism provided. Copper is working like a catalyst. So copper is going to coordinate with this estylenic triple bond. Estylenic triple bond is more reactive towards the coordinate covalent bond formation, so that the complex formation is occurred. Whenever the complex is generated, that complex is going to react with another copper. Another copper is departing one of the hydrogen. Deprotonation is carried, so that second copper is also coordinating with the similar alkyne, so that excessive copper catalyst is required in order to facilitate the reaction. 2 moles of copper are coordinating with this acetylene bond later. This azide is supposed to be treated upon this triple bond. Whenever azide is going to work upon, what happens? Azide is in the form of that dipolar nature, right? So here, wherever 4 bonds around the nitrogen existing, experiencing quaternary nature, so that acquiring positive charge over there, and another nitrogen is subsequently given with the negative charge. This is the way dipolar azide was taken and working on this coordinated stellenic molecule, so that it will giving rise to a polarized 1,3 polarized cyclic transition state. You can notice there is a bonding between the nitrogen and terminal nitrogen with this acetylenic bond, and in addition there are 2 copper metals are also there with this acetylene. They're also forming a kind of transition bonds. This is the way bonding is possible. Slowly you're supposed to remove one of the copper from this kind of a transition complex, we can say, so that one of the copper will be removed, and there is a electrocyclization we accomplished, and giving rise to a kind of what triazole molecule with the copper substitution at the position number 5. So copper substitution is there, so that slowly we are supposed to remove the copper once again, and giving rise to alkylated an alkylated triazole as the final product, leaving copper as active catalyst. So that catalyst is regenerated. It will work again upon another acetylenic molecule in order to initiate that kind of coordination, and followed by this cycloaddition reaction. This is the way Huskin 1,3 dipolar cycloaddition click chemistry reaction will be accomplished, and the copper is the kind of regenerated catalyst. He is able to reinitiate the reaction further, giving rise to a reaction in the faster manner. Another kind of reaction in order to achieve this triazole as the product, that is a cyclization of hydroxides and imidines, right? So hydroxides and imidines are the materials taken as the starting materials in order to accomplish this triazole as the final product. Here is the hydrazine was taken to be treated with this amidins. Whenever amidin, formamide, we can say formamide to be treated with this hydrazine under microwave irradiation conditions, so that it is again the kind of green protocol, so that it will participate in the condensation and followed by cyclization, and finally giving rise to triazole as the final product. This is the way hydrogen derivative to be treated with amidins or carboxylic acid. Either of the compound go for this kind of condensation reaction, so that the final product is expected as this triazole. And this is also explained with the schematic representation. Simple hydrogen was taken and treated with formamide at the temperature 160 to 180 degrees centigrade, and that able to generate a kind of addition product. Later, it will be transformed into a triazole and leaving a water, ammonia, and a formic acid as a byproducts. Being it is a condensation reaction, these are the byproducts generated in addition to the triazole formation. Multi-component triazole synthesis is performed whenever aniline is treated with this active methylene compound diethoxymethane, we can say. No, triethoxymethane, it might be upon the carbon atom, 3-ethoxy functionalities are located, and this CH group is present. And here we have a kind of, this is the one said to be oxime. It is the kind of oxime which is taken as one of the material. It is said to be what multi-component reaction. Multi-component means more number of starting material, more than two if you are taking, that is said to be multi-component reaction. One is amine, another is said to be polyethoxy compound, and here we have tosyl oxime derivative was taken over there, and all together are mixed up. Multi-component triazole synthesis is operated over and giving rise to NRylated triazole as the final product. THF tetrahydrofuran is taken as a solvent, and 50 to 60 degrees centigrade temperature is optimum. 4 hours to 24 hours, 1 hour duration is required in order to accomplish the reaction. In order to achieve this one aryl triazole molecule, aniline to be taken, and aminopyridine is a kind of another pyrimidine is may taken as another material, and here is the polyethoxy compound is also taken. So all together mixed in a single reaction vessel, giving rise to final product a triazole. This is the way multi-component reaction will be accomplished. Then reaction between oxime and aniline, right? Oxime is originated, that oxime whatever we consumed in the last step, in the same manner we are going to treat. So here I'm taking methyl nitrile. That methyl nitrile is supposed to be treated with this hydroxylamine. This hydroxylamine, whenever treated with this one, there is a origination of the kind of double bond NOH. Iminohydrin will be originated and to be treated with the tosyl chloride. Paratoluene sulfonyl chloride will be taken, that to be attached at this oxygen and giving rise to NOTS. This is a kind of material originated. This whatever material originated, this one, that to be treated with this amine. So that an amine, instead of amine, I'm taking this aniline compound. This triethoxymethane is the another material treated over there, and THF taken as a solvent, so that able to giving kind of reaction. So here nitrogen is participating. This nitrogen is participating. Here NRyl group containing one is there. This NRyl group is present over here. This is able to react with this kind of methyl of this compound number 15, so that here is the condensed product generated. Upon this we have NH and a double bond NOTS will be there, and here methyl group is there. Then subsequently the intermediate will be cyclized, giving rise to triazole, where 1 to 4 triazole is the expected product. And the same compound will go with another way of ring cyclization, dimensional change you are going to operate. This nitrogen is taken in the reaction. So initially this nitrogen is taken part of this one, so that labeled nitrogen is directly reacting with this aniline moiety. In between these two nitrogens, the carbon whichever generated will be coming from this triethoxymethane carbon is responsible for this this new carbon linkage over there, and the labeled nitrogen is indicated over. So in order to understand the mechanism, isotopic labeling plays a vital role. That's the reason why this nitrogen and this carbon atom and this amine nitrogen are together reacting in such a fashion and giving rise to triazole by the cyclization mechanism. In the alternative method, let me take a inverted structure of this compound. Whenever inverted structure was taken, this NOTS is supposed to be reacted, and that NOTS and this CHOET taken thrice. This carbon is also taking part in between two nitrogen atoms, and this aniline nitrogen is over here. Whatever aryl linkage mentioned, aryl group mentioned, that is taken as this benzene ring, right? So this is the way N-tosyl is taken over there, and else functional groups are mentioned as such. Here we have double bond NH2. whenever it is reacting, what happens, the double bond will be shifted over there so that it is becoming NH, and that is the labeled nitrogen atom, and methyl remains as such. This is the way linkage positions are different in both the different mechanisms. Further, it is also cyclized in such a manner, giving rise to another again a kind of 1 to 4 triazole only, but the nitrogen position, labeled nitrogen position were interchanged. You can locate here the nitrogen is at the fourth position, labeled one. Here it is at the second position. So based on this, you can allocate the mechanism for this kind of reaction. So that's the reason why isotopic labeling plays a vital role in order to understand the mechanism of the reaction. This is the way oxime will be treated with aniline corresponding. Triazole is the final product. Reaction between the carboxylic acid and the amidins. Carboxylic acid and amidins to be treated. Just now we gone through that one. Carboxylic acid may either carboxylic acid or else a formamide to be treated with hydrazine, right? In the same manner, this is also the kind of the reaction, carboxylic acid and amidin to be treated over there in the presence of dimethyl formamide and any other reagents also taken part of this one, so that again condensation is accomplished, simple dehydration giving rise to alpha ketoimine. Alpha ketoimine is the kind of transition compound which is mentioned in the square bracket, being it is not isolated. So that let me mention the square bracket. Alpha ketoimine is the product generated later. It may treated with this hydrogen compound. Hydrogen to be working over there that able to generate this triazole as the final product. This is the way the carboxylic acid and what it is amidins are together are condensed. This is the process said to be condensation and subsequent cyclization to be proceeded, giving rise to triazole as the final product. Let me go for the industrial scale synthesis. Bulk drug synthesis is also possible, right? In order to synthesize the compound in the bulk manner, industrial scale synthesis to be taken. Benzyl bromide is the one of the starting material. Sodium azide is another one, and this acetylenic. Phenyl is the another one. Phenyl is another starting material taken together. Sodium ascorbate is a catalyst working. Tertiary butanol and water 1:1 ratio. This is the mixed solvent media. Alcohol and the aqueous media were taken together. So that as we already aware, this azide is going with what 1,3 dipolar cycloaddition upon this acetylenic linkage, giving rise to this triazole molecule. Whatever this benzyl bromide is there, that frankly go for enalkylation only. The reaction actually performed in between this azide and acetylene itself. Whatever benzyl bromide we have, that to be taken as the alkylation upon the nitrogen. Nitrogen will be benzylated. This is the way N-benzyl 4-phenyl triazole is the expected product, right? So instead of sodium ascorbate, you may go with the copper foils as electrode, so that we can achieve the same product. Same product will be accomplished. This is the industrial scale manufacturing of triazole. Synthesis of triazole starting from the carbonyl urea. Urea may taken as a starting material, where I am taking alpha keto urea molecule. We are having bulkier functional group further. We are not taking that entire one into the consideration. Our requirement, our focus purely upon this urea part only. Whatever urea part we have, that to be treated with this hydrogen hydrate. Hydrogen hydrate is working upon this kind of urea molecule, so that it may go for the cyclization reaction subsequently, condensation reaction, giving rise to triazole at its core, and whatever functional groups we have. Benzene ring, and this keto remains as a CH2 is there, CH2 remains as such, and benzene remains as. The things whichever participated in the reaction are this ketonic functionality, which is active in the condensation reaction with hydrogen initially. Later, it will go for this ring cyclization with this carbonylic functionality, right? So initially, hydrogen will condense with this carbonyl functional group. Later, another NH2 will condense with this carbonyl functional group, so that this NH2 will become a side chain. Here you can locate that NH2 as a side chain. This is the way you can generate simply by condensation of this alpha ketonuria with hydrogen hydrate, giving rise to triazole as the final product with the side chain, same side chain without any chemical transformation. By that, we successfully complete the entire process of synthetic protocols in order to synthesize triazole in a viable ways of laboratory methods and the industrial methodologies as well. Let me deal with this physical properties of triazole. How can we explain the physical properties of triazole? Molecular formula is recorded as C2H3N3, where two carbons and three nitrogens and three hydrogens are the part of this triazole molecule, whose molecular weight is accompanied as 69.07 gram per mole, and it appears like a white crystalline solid. It will be a solid compound, and whose melting point at the temperature of 23 to 25 degrees only. If it is mentioned as 23 to 25, so that generally it will be a liquid one. What happens by lowering the temperature, then only solid compound existence is possible. In general, it will be the liquid only. So that there are two possibilities, just like phenol. If you are taking phenol, what happens in winter season, it is a solid one. In summer season, it is the liquid. In the same manner, this triazole is also uh, uh, beyond the 25 degrees, it will be the liquid one. Below the 25 degrees, it will be the solid one. This is the way you can get the transition for this compound. And the triazole boils at the temperature 120 to 121 degrees centigrade only, extremely lower temperature, so that we can assume that it is volatile again. Approximately 260 to 265 degrees centigrade decomposes before boiling, right? So this is the way uh, sorry. So melting point of 1 to 4 triazole is given as 120 to 121 degrees centigrade. It is again mentioned as melting point only, but boiling point is given as 260 to 265 degrees centigrade. Make a correction. And density, obviously, being it is a kind of solid material, its density will be slightly higher, so that 1.3 to 1.4 gram per centimeter cube density is accorded for this triazole molecule. So this is the way all physical properties are taken, which is a a monocyclic ring system with the three heteroatoms within the ring. Three nitrogens are taking part of the single ring. And solubility, being all the nitrogens are dominating within the molecule, so that polar solvents are more suitable in order to dissolve, and more conveniently water solubility we can absorb. So whenever it is added to water conveniently, it will go for the solubility, and even polar solvents are more susceptible to dissolve the substance in complete solubility. That's the reason why it is more preferable for the polar solvents to dissolve this triazole, because of the polarity. By the physical properties of the triazole were completed, let me step into this chemical properties of triazole. Why triazole is said to be aromatic? The question arised. In order to answer this question, there is a cyclic structure accompanied by the compound five-member ring system, three nitrogens taken part of that one, and continuity in the pi electron delocalization, and planarity is also accorded, being all the atoms, including with the carbons and nitrogens, are the part of sp2 hybridization. So that planarity is the essential part of this aromaticity, and effective orbital overlap is also taken part of this one, and it is enclosed with the delocalized pi electron system. 6 pi electrons are taking part of this one, and moreover 5-membered ring with 6 pi electrons, pi excessive ring system. 4 and plus 2 pi electron rule is best obeyed, hence it is following the Huckel rule, so that aromaticity n is equal to 1 integer value is obtained whenever you are substituting all the values over there, so that 6 pi electrons are making this aromatic in nature. And delocalization is the common characteristics of this triazole molecule, is incorporating this aromaticity within the molecule, indeed stability as well. resonance. More number of resonating structures are available for the compound because of the delocalization of pi electrons. Always they are non-static in nature, and the kind of delocalization is the most common observation, so that we can indicate the all pi electrons as a ring system instead of the bond system being all or mobilizing always. So that resonance is a common characteristic for this, and this kind of delocalizing structure, canonical structures, are observed for the compound. And if you want to observe the kind of pi orbital overlapping among the lobes of p orbitals, and hybridized p orbitals are always taking part of this pi bond formation. Each p orbital of the ring system are accompanied by odd electron. One of the nitrogen is accompanied by two odd electrons, so that entire pi electrons contributed by the system are 1, 2, 3, 4, 5, 6, 6 pi electron system it will be. So it is taking part of this aromatic ring system, and they are laterally overlapping, so that a pi cloud is covering above and below of the plane. This is the way unhybridized orbitals are forming pi bond. Already sigma bonds are located in between all the atoms in the pi member ring vicinity. And isomerism is also the kind of nature exhibited by these compounds. If you are taking one of the nitrogen is protonated in general, but when it is participating in the process called tautomerism, the shifting of hydrogen from one position to another position might be taken, so that first to second position. So here you can locate the hydrogen. 1H triazole may transformed into 2H triazole as well. That is that is the process called tautomerism. Again, this 1H triazole of 1 to 4 triazole may participate in the same kind of hydrogen transfer, and this is also taken as the part of this tautomerism. So here first to fourth nitrogen hydrogen shifting is observed. That is the reason why 1H triazole now transformed into 4H triazole by the process of tautomerism. That is the part of isomerism. And already we gone through the resonance. More the number of resonating structure, more will be the stability of coordinate for the compound as a part of aromaticity. And the resonance hybrid is manifested over there if you're combining all the resonating structures, so that resonance hybrid will be extracted. And that compound already exists in this protonated form itself, but it able to go further protonation by the addition of water. Whenever water is added, water being working like a amphoteric in nature, so that it able to pull up this hydrogen. So hydrogen taken up by the water, giving rise to N negative, and this counterbalanced with this oxonium positive. So this is the way, this is said to be what deprotonation in general, protonation of water carried, not protonation upon the triazole. This is the evidence for the acidic nature. It is losing, even the weak base is able to pull up this hydrogen from this triazole, giving rise to triazolium anion. Triazole anion will be generated. Triazole anion will be generated. And now we are going to discuss about how can we perform this electrophilic substitution reaction upon the triazole. Only the two probable positions are either C4 or C5. No other position, because all three positions are locked by nitrogens only. Only two probabilities we have, either position number 4 or position number 5 can located with this electrophile. So the two probabilities are mentioned here. C4 and C5 positions are suitable for this kind of electrophilic substitution. Let me perform with this nitration. Nitration can be carried upon this triazole by treating with this nitration mixture. Concentrated nitric acid and sulfuric acid together regarded as a nitration mixture, and can be operated at room temperature for the period of 3 hours, so that the nitration will be accomplished at the position number 4. If you are continuing the same nitration further by adding the excessive reagent quantity, so that polynitration is also the kind of product you can achieve. Mononitration and dinitration is also possible. That depends upon the concentration of the nitrating mixture you are adding with. This is the way nitration of triazole is accomplished by substituting at the position number 5 and position 4, 5 together. Let me perform the halogenation reaction upon this triazole. It may accomplished by adding bromine dissolving in water. Bromine water will be the reagent working, and temperature required 50 degrees. That is not much high. At 50 degrees centigrade, it will be brominated, giving rise to dibromo triazole as the product. Or else it is also possible to treat with the NaOBr giving rise to a kind of bromination. It is some extent powerful brominating agent you can consider, so that tribromo product formation is possible. Even nitrogen is also brominated, and bromination is also the part of this kind of a strong brominating agent. This is the way halogenation of triazole taken part. Let me add lithium metal over there. Metallation of the triazole is the reaction going to be performed. N-phenyl triazole is going to treat with the N-butyl lithium. This is the organolithium catalyst, and dissolving the tetrahydrofuran catalyst, so that what happens? Lithium positively charged one that able to bind up at the position number 5. So here, whenever lithium positive is coming, what happens? That H positive will be replaced, right? H positive will generate N-butane as the byproduct. This is the way lithiated triazole is the final product. Lithiated triazole will be the final product. Sulfonation is also the characteristic reaction of triazole to be performed with the fuming sulfuric acid, being it is a certain extent deactivated towards this kind of electrophilic substitution. The reason behind this will be, though it is the kind of pi excessive compound only, but more number of electronegative atoms are operated, electronic factors are dominating over its by excessive nature. That's the reason why certain extent of vigorous conditions to be applied in order to perform this kind of electrophilic substitution. So that instead of concentrated sulfuric acid, let me add fuming sulfuric acid, so that vigorous conditions are able to generate the electrophile and subsequent sulfonation at the position number 4, giving rise to the triazole sulfonic acid as the final product. By that electrophilic substitution successfully completed, let me operate upon the nitrogen. Nitrogen in alkylation, in acylation, nitrogen substitutions are also the criteria you are going to observe. In order to achieve that kind of reaction, I am taking this sodium salt of triazole, salt of triazole to be taken. In order to form the sodium salt of triazole, what to be the starting material? So the triazole, whenever treated with a strong base sodium hydroxide, what it will do? Hydroxide ion will pull up that H positive, and ultimately water will be the byproduct, and the sodium salt of triazole will be the kind of salt originated, right? So that will be treated with this acid chloride. Acid chloride is working upon, being it is a acylating agent, so that in acylation is accomplished, acyl 1,2,4 triazole is the product expected by N substitution. And in the similar manner, enalkylation is also possible. In order to operate enalkylation, this is the kind of vinyl olefinic compound to be operated over. Olefinic compound, whenever treated with this one, what we are adding as NIS? N-iodosuccinamide. This is said to be what? N-iodosuccinamide, which is abbreviated as NIS. N-iodosuccinamide is working like a catalyst in order to facilitate the reaction, so that the pi electron cloud of this olefinic double bonded to be added to the iodine. At the same time, nitrogen from this triazole is taking the reaction with this carbon atom. One edge of the olefinic carbon is binding with this iodo. Another edge of the carbon will binding with the nitrogen. So that what happens? This carbon is able to bind up with this carbon, so that nitrogen to carbon linkage is noticed. That is an alkylation in specific. And whatever another side of the carbon is there, which is taking the iodo group, right? So that iodo functionality is taken into the reaction. And already we have R3 upon this carbon atom, so that R3 is also mentioned over there. This is the way an alkylation reaction is accomplished. Later, let me perform the same kind of reaction by taking vinyl ether. This is called vinyl ether, and the catalyst working is RM. Gold is taken as a catalyst over there. In order to accomplish this reaction, there is another kind of methodology, another kind of mechanism is operated. Being metals are electropositive, having tendency to bind at the position of nucleophilic carbon atom, so that it is coordinatedly binded to this olefinic one. And whenever ORM is binding to one position of the carbon, another position of the carbon is susceptible for binding with this nitrogen atom. There is a enalkylation occurred. There is a enalkylation. Whenever enalkylation is enalkylation is possible, subsequently, adjacent to position we are having OR4 that remains as such. Here we have R3, and this RM is departed from the system. RM is departed from the system, and that carbon whichever negatively charged will be protonated. So that protonation of this one will be carried. So this proton is shifting to this carbon atom wherever RM molecule is departing. This is the kind of transition compound in order to achieve this enalkylation once again. So there are the possibilities for enalkylation. So the suitable catalyst and olefinic compound to be added in order to achieve this kind of enalkylation reaction on triazole molecule. Let me go for enalkylation in another perspective. Triazole to be treated with simple alkyl halide, so that enalkylation already alkyl group is there on this triazole in the starting material itself. Another alkyl halide, if added without any catalyst, that is prone for this enalkylation in general. Enalkylation is accomplished. The same kind of triazole to be added with this azamethane. This molecule is called CH2N2 is called azamethane. Azamethane is the reagent to be operated that is going to attach to this nitrogen with respect to this first nitrogen. Second nitrogen is going to be substituted uh, because it is the kind of carbene originated. The mechanism is proceeded with carbene intermediate and that able to generate a kind of selective substitution over the second nitrogen rather than first nitrogen. First nitrogen alkylation is possible by simple alkyl halide. Carbene based azamethane carbon-based alkylation is carried at the position number 2. This is the way distinctive factors are operated in order to achieve the expected product. So that we need to go through the literature in order to achieve the expected product on this triazole. Again, enalkylation is the case to be continued. We are going to discussing. This is a triazole to be treated with this alkyl halide. Rather, let me treat with the aryl halide, chlorobenzene. Trinitrochlorobenzene or else a trinitrophlorobenzene is the alkylating agent over there. Dimethyl formamide is the solvent operating over. And this alkylating agent is suitably working on this enalkylation only. Either chloro-fluoro, both are having similar function in order to alkylate upon this nitrogen, giving rise to enarylation, right? So enarylation. In order to operate this one, electron withdrawing groups and the benzene will preferentially required in order to achieve this enarylation process upon the triazole molecule. By that, nitrogen substitution reactions were successfully finished up. Let me discuss about the oxidation reactions. So, triazole molecule is suitable for the oxidation reaction, metachloroperbenzoic acid. If operated, this is the kind of peroxy compound. It is more susceptible for N-oxidation. N-oxide formation is accomplished so that you can achieve N-oxide, right? So N-oxide is also the kind of oxidation. Addition of oxygen is accomplished, right? So that metachloroperbenzoic acid is operated upon the triazole, giving rise to N-oxide as the final product. And the same oxidation of triazole is carried in the presence of potassium permanganate or else chromic acid. H2CrO4 is also designated as chromic acid, that giving rise to a side chain alkyl oxidation, right? I'm having methyl substitution over the position number 4, that to be oxidized either by potassium permanganate or chromic acid. Both are strong oxidizing agents, obviously, that able to generate carboxylic acid functionality, being it is an oxidizing agent for alkyl side chain. Let me enter into the segment called reduction process. Triazole to be reduced in the presence of either lithium aluminum hydride or hydrogen palladium carbon. Both are powerful reducing agents only. That's the reason why entire aromaticity will be destroyed, giving rise to saturated molecule, so that we are achieving tetrazoline as the final product. And this is said to be nucleophilic substitution. So already any nucleophile existing on the molecule to be substituted by the suitable reagent, what we are adding, either ammonia, amine, or alkoxide and thioalcohol to be treated, thiols to be treated upon this substituted triazole, giving rise to that nucleophilic substitution. So that let me take a kind of 4-chlorotriazole as a starting material to be treated with this amine. And the chloro obviously replaced with this amino, giving rise to NHR. Instead of NH2, let me put NHR here. There should be a R group because HCl will be removed, giving rise to NHR as the functionality over this triazole molecule. By that, we successfully accomplished the section called chemical properties of triazole. Let me introduce applications of triazole. Triazole is most active compound towards the disease curation and also other medicinal chemistry applications and material chemistry applications, agrochemical applications as well. Fluconazole, we already gone through this one. Fluconazole is a kind of triazole moiety containing molecule with conjunction of fluoro functionality over the benzene ring. Together, they are amplifying the activity again is the fungal infections, and the fluconazole is effective kind of fungal infections. You can notice whatever kind of skin allergies, skin infections you can observe that effectively curated by fluconazole drug. And ribavirin is the kind of another drug. You can notice effective pharmacophore is this triazole, and that is in enclosed with this amide linkage at the position number 3. And here we are having a highly polar functionality over this nitrogen. This is most polar functionality is located upon the nitrogen. This is effective antiviral agent. A kind of viral infections will be effectively destroyed by means of this ribavirin drug. It is a marketed one. And doravirine is a kind of drug which is also included with this triazole as the effective pharmacophore. It is the anti-HIV drug. You can observe three-dimensional representation of doravirine. So this is the way human immunity destroying syndrome will be removed by means of, curated by means of this doravirine. And BBATT corrosion inhibitor. BBATT is a kind of a trade name allocated for the compound. It is the effective corrosion curative agent that is mentioned, and where you can observe the kind of effective curative one, effective corrosion inhibiting moiety will be a triazole molecule only. It is a kind of dimer, it seems to be. And here we have thioketone functionalities over there, and enamine linkages are also observed. It is the dimer compound. It is effective again as the corrosion tendencies. And it is also working like an ionic liquid. Ionic liquids are most important in phase transfer catalysis process. And in agrochemical applications also, you can notice these triazole molecules. Here, if any crop is suffering with the pests, so such kind of pest effectively curated by means of these triazole molecules. So agrochemical, so many agrochemicals are synthesized in order to work in the field of agricultural field to remove the pest causing the crop destroying. Triazole working like a herbicide as well, and so many herbicidal agent. Amitrol is a kind of effective, this amino functionality containing triazole was taken, and the same triazole linker is present in between the polyannular system, and also this is a kind of indolinone molecule is there, so that it is a thiazole linker is effective in this herbicidal activity. Any weeds and undesirable plants if present in the croplands will be effectively destroyed by means of spraying this kind of herbicidal drug. And the material science applications also vital for this triazole molecule. Triazole is more potent towards the formation of triazole polymers. So here you can notice the coumarin based triazole polymer is located. This is synthesized by means of click polymerization, and indeed biomass polymerization process is employed for this one. And that polymer whichever generated is having strong adhesive tendency upon the copper plates, so that it is effectively coated on the copper plates as a adhesive, right? So that corrosion tendency will be mitigated. By this, we successfully accomplished the session covering the entire matter related with the triazole, where it is originated, where it occurs, and what could be the intro regarding this triazole molecule, and what are the synthetic strategies in a laboratory viable method and synthetically industrial application methodologies for bulk manufacturing of that one, included with their mechanisms and physical properties exerted by the compound, and general chemical applications in a laboratory reagent analysis. And also we gone through the applications in the various fields, applications of these triazole molecules in various fields, including with the pharmacology, medicinal field, agrochemicals, material chemistry applications. These many kind of potential applications are given for triazole, so that it is more informative towards the researchers, scholars, academicians, and competitive examination aspirants, entrance examination aspirants, and also various domains, those who are working with this chemistry, pharmacy, and material chemistry. So hopefully the session is most useful towards the viewers, and the session conducted by Dr. Kavita Kottireddy Kota. Thank you very much for your patient listening. Thank you one and all.